Hello students, this is Professor Sagar Birje and I welcome you all for the online class for analog and digital electronics. In this presentation, we are going to discuss on the generalized procedure to simplify the Boolean expression using K-map. So here we are going to discuss two generalized procedure for the Boolean expression in sum of product form and the Boolean expression in product of sum form. So let us start with the first part, that is your sum of product form expression. So the simplification for the sum of product form expressions are, you have to plot the K-map and place the ones in those cells corresponding to the ones in the truth table as sum of product expression. So you have to have a K-map for the given Boolean expression or the truth table and then place the ones in those cells for the respective product terms of your sum of product expression. The second one is check the K-map for adjacent ones and encircle those ones which are not adjacent to any other ones. So these are called as isolated ones. So find out those ones which do not have any adjacent ones to them and then encircle those ones. These are called as isolated ones. Then you check for those ones which are adjacent to only one other one and encircle such pairs. The fourth step is to check for chords and octs. Chords are nothing but group of 4 ones and octs are group of 8 ones where each one is adjacent to each other. Of adjacent ones, even if it contains some ones that have already been encircled, you have to group them, but while doing this you have to ensure that there are minimum number of groups. The fifth step will be to combine any pairs necessary to include any ones that have not been grouped yet. So you have to ensure that all the ones that are plotted in the K-map have been grouped with either of the adjacent cells. And finally, after all the ones that are plotted in the K-map are grouped, you have to form the simplified expression by summing the product term of all the groups. So these are the some of the generalized procedure for the simplification of sum of product expression. Just we have a quick review of the procedures. First, plot the K-map and place the ones in those cells which are corresponding to the ones in the truth table as sum of product expression. Then check for the K-map for adjacent ones and encircle those ones which do not have any adjacent ones to them. So these are called as isolated ones. Then you have to pair the ones with two ones which are adjacent. We call it as a pair. You can check for chord or oct. Chord stands for 4 ones. Oct stands for 8 ones which are adjacent to each other. And then combine any pairs necessary to include any ones that have not yet been grouped. And finally, simplify the expression by summing the product of term of all the groups. So these are some of the simplified expressions for SOP. Next, what you have is the simplification of POS expression. The procedure for simplification of POS expressions are: plot the K-map and place the zeros in those cells corresponding to the zeros in the truth table or max term in the product of sum expression. So in sum of product expression, we are going to plot the ones in the cells, whereas in this product of sum expression we are going to place the zeros in those cells corresponding to those zeros in the truth table, or we call them as a max term in the product of sum expression. So check the K-map for adjacent zeros and encircle those zeros which are not adjacent to any other zeros. These are called as isolated zeros. Then we need to check for those zeros which are adjacent to only one other 0 and encircle such pairs. In the fourth step, we need to check for chords and octs of adjacent zeros. Even if it contains some zeros that have already been encircled, while doing this, you have to ensure that these are minimum number of groups. And then combine any pairs necessary to include any zeros that have not yet been grouped. And finally, form the simplified product of sum expression for the function f by taking the product of sum terms of all the groups. So these are some of the generalized procedure for the simplification of product of sum expression. So here instead of making the group of ones, we have to make the group of zeros. So each group of zeros results a sum term and it is nothing but the prime implicate. So these are the techniques which we are using for simplification of the product of sum expression. Just a quick review. Plot the K-map and place the zeros as it is a product of sum expression. We call as the max term in the product of sum expression. And then check for the K-map for adjacent zeros and encircle those zeros which do not have any adjacent to any other zeros. We call them as an isolated zeros. Then go for pairing of zeros. A pair consists of two zeros which are adjacent to each other. Then go for chords. It is a group of four zeros which are adjacent to each other, or octs, which where we say 8 zeros which are adjacent to each other. Mark them, and if there are already zeros which have been grouped from the other pair, uh, encircle them, but make sure that there are minimum number of groups. And finally, combine any pairs necessary to include any zeros that have not yet been grouped, and then form the simplified POS expression for the function f by taking the product of sum terms of all the groups. So students, these are the two simplification rules. One is the product of sum expression and the sum of product expression rules that we are going to apply in simplifying the Boolean expression, which is in sum of product form or in a product of sum form, and using K-map. So the rules for the procedure for plotting simplification of the sum of product expression, the changes is there we are going to group the ones that we call it as the mean terms in the sum of product expression, and here in the product of sum expression we are going to group the zeros where we call it as a max term in the product of sum expression. So hope you have understood this procedure. Later we'll be applying this two procedure in simplifying the expression using K-map, and we'll be looking towards solving more problems and applying this procedure. So as and when you solve more number of problems, you will be able to understand the procedure in a better way. So hope you have understood both the procedures and you'll be able to apply these procedures while solving the K-map simplification technique. So students, in the next class we will continue to study and understand on the K-map minimization, different examples on K-map for 2, 3 and 4 variables minimization. Thank you. Thank you for patiently listening and watching this presentation. Hope you have understood the concept that we have discussed today. Thank you.